Alright, we're back. Okay, so we just dialed this in. Pretty much on 5 all the way around. Don't know if the light's hurting or helping at this point, but our low spots over here were about 4, 4.5 maybe. These are half thou increments, not 1, so we're probably half a thou off. Probably close enough. Okay, so now we'll go ahead and zero this out up here. Okay, so now we're 0. Okay, now what we're going to do is we're going to go ahead and indicate in this back wall right here where it's cut for counterbore right there, and that should give me side to side location pretty good. Hopefully. We don't have exactly 100% even area there to work with. We're going to go ahead and go with it and try to get something out of this. Right now the hole is not centered like this. Here it's slightly like that, so it gives us an error. There is going to be an inherent error in this design. So what I'm looking for is no movement of this indicator. Okay, so that's going lower, that goes high. So we're compressing the needle more on this side, so that means it needs to go that way. About 10, about 11. This went too much. We went 12,000, so let's come back 2. Close to 2. Okay, there's 10. Oop, don't go off scale. No, I didn't like that at all. So we're 10 over here and we're 13 there, so that sucked. Okay, so we're bouncing from 10 to 11 right there. Over here, 9.5, 10.5. So 12.4 thou. It's 13, wrong way. I'm going to take 1 thou out of this, put 11. There's 11.7. That makes a big difference when you do that. There's 12.3. It's about 10.5, 11 there. 10, 10.5. Okay, and right here in the middle, we're at 13. Okay, so now we need to go this direction here. So in the Y direction, which is going this way here, pull back a little bit. This is Y, and this is X. So this moves the table this way, this moves the table in and out. So I've not been moving the X-axis, I've been moving on the Y. So at 12.3 we're close. So I'm going to go ahead and zero that because we should be pretty close. Now we're going here, you can see it's, I don't know if you can see that, sometimes the light helps, sometimes it hurts. So see you're bouncing around right around the 10 number there, 10.5, that's 10.5, that's 11 there. We're going to about 13 right there, and we're back down to about 10, 10.5 over here, see. About the same that way, the middle's off. So we need to move this until this gets closer to 10. That's the wrong way. That was a big move. Okay, there's 10. So I moved it 2.8 thousandths up there. Okay, now we're going to look at our numbers, see what we got now. Our number went down, so this number needs to go more. Okay, we just want another 7 thou more. Okay, now it's going up when I turn it, so I've gone too far that way. This side here looks good though. Now, looks like I can go a little deeper here, so I'm going to go down a little bit. I'm going to go ahead and move the table here a little bit. You go down until you bottom out. When you bottom out, your indicator is bad. Okay, 13, 10 way over here, 10 there. Okay, so now we got to move our Y a little bit, because we're off. We zeroed that number before, so now we're going to move it a little bit more. That was 1 thou in the plus direction. I think that's the wrong direction. Nope, that's the right way. So we moved to 1 thou, so I think we need to go probably 8/10 more. There's a full thou more. Let's see what that looks like over here. A little bit too much that way. So 2 is too much, so we want like 1/7, I think. 1/7. Can we go get this to somewhere we get close to a number? Okay, we're right there. So we drop down. So you're half a thou under, 1 thou almost under. There's 1 thou. Half a thou. About 0, and then we go about a half again over there. It's very uneven. There's a big burr on the edge, so we make a big burr at the end. That's a burr, so that does not count. So we're half down that way, and over here, about a half a down also. In the middle, we're not quite half. Right there we are. So we need to move it just a little bit more. We're at 5.7 thousandths right now. Go ahead and zero that one out. I'm going to re-zero this one also. Let's move it a little bit. Come on, move. It moved 1/7 when I hit the hammer. Okay, that's a half a thou movement. Let's see what half a thou did for us. I'm going to move this one too. Couple tenths. About 1 under, 1 under, 1 under, off scale. Okay, I think we're pretty close now. There's our 5. Okay, right there. Just under 5. Still bouncing around under 5. We go off scale. About half under. Okay, I think we're pretty close. Alright. Tenths make a difference, see? Okay, so now I'm pretty close on this crescent cut. So that's all I can go by for reference. Now the last thing I got to do is references off of the shiny titty down there in the inside of the hole. Right down there, that's our screw. That shiny part. It's about 1/3 on this third of the hole. So I need a little small drill bit to use a reference tool. So what size are these bits? It's our smallest. This is our smallest one. This is probably 1/8 also. So our smallest collet is 1/8. So I'm going to look for an 1/8 inch drill bit or something close to an 1/8 inch. It can be a little bit smaller, but not a lot. So these are 111 way over here. This is a 116. See, that doesn't fit very good in there. Let's go with a bigger one. Too big. I think it's going to be right on the 8th. Well, you got 120 or 128. It's going to be one of these two here. This one should be a little bit loose. This one should be a little tight. It is. The problem is this is way bigger than our screw. But that's what we're going to have to use. Okay, so now I'm going to take this out and put the drill bit in there. We gotta get this out of our way. Everything I did there could be done with a drill press. This part you can't do with a drill press, you can only hold it with a chuck. A chuck is usually not very accurate. So you have to spin it, and if it wobbles, you got to kind of average the air to get accuracy. Hey, dumbass, put it all the way up this time. Yeah. Well, now, hopefully this is pretty straight. That means it's not wobbling. And as usual, it is what it is. So you have to look to see if you think it's wobbling or not. Looks pretty straight. Okay, so I'm going to move it over until I can drop it down and look down that hole. It'd be nice if this was half the size of this so you can see the screw behind it, but in this case we're going to drop it right next to the hole. I'm going to rotate it, and there's a point and then this drill bit. I'm going to try to get the point to be exactly what I want to be. Now if I put this at lower RPM, should be able to watch it. Now, got to turn the phase converter on back here in the corner. Yeah. Okay. Now you gotta look at your point. You want to get a dead nuts in that hole. My problem is I can't see the hole. Well, I can't see the part in the hole with the shadow. Pretty much in the middle of the hole, this angle. It's causing more issues with trying to visibility than it's helping me spinning. So it's really hard to see exactly what we're looking at over there. Like when he's turning this, making a light reflection, you can't tell where it's at. Okay. What's different this way either? Looks like there's a hole all the way down. It'll actually help us. I think we're pretty damn close. So, right now, if you look in here, there's a hole right here. And I think that's the same hole that it drilled straight through for the other hole, which was up here. So you can see through there. I think this hole here is done with the same bit. So the more angle, the more length you go, the more accurate it gets. When you drop from that hole all the way down to here, you double the distance. The accuracy goes up really quick. So I think we're pretty damn close. Gotta get the camera right where it's centered. The camera should be pretty well centered with the screw right there, so I think it's pretty close. Anyway, it's pretty close. Might be off by 5 thou, but it should be pretty damn close. So that 0 we had up there, we're using it. Okay, so I'm going to use the same number I had. I'm going to put this here right back on the same 0 we had before. So I think we're within usually within a couple thou, probably within 5 easily, if not closer. I think it's probably closer. So you got to play with this until you get what you need. Sometimes you just hit the table a little bit, it changes it. Yeah, I went to -2. Right there, 0. Yeah, I went to 1. Oh no, I moved to 1 too. Oh well. Screw it. Alright, so I think we indicated in that circle we got this diameter. The cutter was probably on the money and everything was pretty close to what it should have been. So we're very, very close. Okay, so now I cannot hit this on here because see this moves. So it's not gonna, it's gonna follow the bad hole here and walk all over the place. So we have to go to a center drill. Okay, let's try to put out of my way. Lack of room as usual. So here's center drills over here. We got a number 2, a number 3, a number 4, and a number 5. The difference is the diameter of the bit. You can see how it goes up quite a bit in size. So that's also what changes is the tip angle here, which the drill bit is right here. That changes also. So it gets bigger. The bigger you go on the bit, the bigger that gets. So we got a tap drill size for this. Indicator on my way. So there's a certain hole size for this thread, and for 1032 we can look that up. And if you go bigger than that, then you'll be cutting the thread out for sure. Now the bigger you make this, the more accurate it is too, because it's going to want to bounce. Even this is going to want to move around a little bit. Now the drill bit is stronger here because it's more thicker shank, or the web in the middle is thicker. Plus you have it backed up by this big thick solid piece behind it that's only a 1/4 inch away. So this is very rigid compared to a flimsy ass drill bit that has very little web strength through here, the web through the middle, and it's very unsupported. Go that far. So, center drills get you more accuracy. So I'm going to use probably this one or this one. I'm not sure what you have. Okay, so you go over to tap drill. Tap drill size is 1032. Is a number 21 drill. Number 21 drill. $159,000. So how big is that? I don't know. So you take your indicator over here. Caliper, measure it. One's 108. It's hard to do with one hand. 135, 136. Okay, so 136 is nowhere near or number 21 drill, which was here, 159. 36 is way up here at 29 drill. Okay, so that means we can use this one here to spot it, and we will not be cutting the thread out right here. Now, it looks to me like we'll be cutting that thread out, so let's measure that screw and see what size it is. Maybe it's not a number 10, it might be a number 8. Sure looks like a number 10 to me though. Okay, so 10's 189 thou. Okay, this one's 186, so it is a 3/16. So we should be okay with the small bit. Let's come over here and measure it for real. Still only 136 thousandths, so this should be good. It's not going to cut too much, and it'll cut the screw out pretty good. Now his drill bit. This is the drill he got, and it appears to be 124, so it's an 1/8 inch bit. On small drills, if you measure the shank, it's usually the same size as the drill. So right here we're 124. If you go out here on the actual cutting edge, 124, 123, 124, 124. Same thing. Okay. So that means this is 136. This will cut a clean hole for this to go into 100% support, because this has that tapered wedge going, drill it in. It's like a countersunk hole. So this will be centered completely, so it won't walk around. It'll go straight down with what we want it to be. So should be the car. All right. Let me get this set up. We'll be right back.